Hi everyone. Now in this particular one, we'll try to understand what is machine learning, and we'll try to understand the entire aspect around it. That what exactly do we do in machine learning? How do we train the machine learning models? What are the components of machine learning? And basically how is the entire life cycle and types of machine learning algorithms. Okay. My name is Anirudh. I'm founder and director of Fireblaze AI School, and I'll be taking this particular one. Now, the basic agenda, if we try to discuss first that what exactly are we trying to do over here, is that we'll try to hover over the topic that is what is machine learning. That is the introduction to all of it. We'll try to understand what are the parameters which come under machine learning, or what are the key terms which we basically utilize to work around what exactly do we do in machine learning, and what all things work and how they are. Then we'll try to understand the processes around it. We'll try to explore what are the types of machine learning algorithms and what are the problems. So what are the different types of problems which we can solve with respect to the machine learning algorithms. Okay. So basically, let us just try to discuss the first definition, which was given by Mr. Tom Mitchell, that a computer program is said to learn from experience E with respect to some of the class of task T, and performance measure P if its performance of or at the task T as measured by P improves with the experience E. So this is a highly complex what we can say a definition which basically comes over here, but if you try to just hover it over and try to understand, there are three different things, like one is E, one is T, and one is P, right? That is performance, experience, and task. So on the basis of basically, if I just try to cut it down, what exactly does it mean is that on the basis of different experiences and task, the machine learns, and it can be measured with respect to its performance, like how it is performing those tasks, right? So basically the parameters, or say if we just say, let me just go back and try to like give you or share a little more light over this particular topic. So see, let me tell you this one thing. Now, basically, whenever we say that the machine learning algorithms are there, right? So the core thing which we are working around is basically some sorts of statistical steps. Now, say for an example, if I am telling you that, okay, I need to get algorithm to reach to Bangalore airport from say HSR layout or anything of that sort, right? Now, how would the navigation work basically? So you'll be able to say that, okay, take a first left, take a second right, go straight for 20 kilometers, you'll reach a highway, Hyderabad highway, and then you'll have to go somewhere around 20-24 kilometers straight, then take a right roundabout, and then you'll reach the Bangalore airport, right? So whatever are these steps which I am giving you basically, so these are nothing but these are your algorithm. So algorithm in short is nothing but steps to do certain thing. Now when these steps are highly statistical, mathematical, and the outcome of it is some kind of predictive or a forecast. It could be anything. It could be like, say, a value, a yes or no value, or a pattern or an anomaly or anything. That is nothing but your machine learning algorithm. Okay. So on the basis of previous experiences, we try to understand and train the machine. And this is done by a highly statistical mathematical approach. And then whatever is the outcome is the predicted output. And then you'll try to check it out with respect to your existing answers and try to tell that, okay, this is much is the efficiency, this much is the accuracy of my particular model. Okay. So now when we try to dive deep into it, perfect. When we try to dive deep into it, we need to understand that what are the basic parameters of machine learning. So over here, if you try to understand the first parameter which comes is algorithm. So whenever we say that algorithm, now everyone has an understanding what exactly is algorithm. Algorithm is nothing but steps to do anything, right? Now a machine learning algorithm is a set of rules and statistical technique used to learn patterns from the data, draw some significant inference out of it, right? A logic behind a machine learning model. So basically, how does a baby learn to talk, right? This is my favorite comparison. How does a human baby learn to talk? What do you think? We try to say or repeat a word 100 of time in front of that kid, right? We try to say mom, 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 mom. And then one fine day the baby will interpret from those historical data given by his parents to say mom. And then the baby will start to reciprocate it. Mama, mama. And then again they'll say, okay, say mom, not mama, mama, mama. There is something different, right? So then it will slightly tune it up, update it, and try to figure out and then learn and say mom. And then after significant improvement, it will end up saying mom to everyone. Is it the case, sir? No, right? So then you will tell that, okay, this particular lady who has a sari, who has a bindi, and who looks like a particular shape, or beautiful eyes, this particular lady who takes care of you is your mom. Then again, the baby will learn and adapt. And then that is how baby will start recognizing that, okay, this particular lady is my mom. Similarly, all those steps which would come to give that baby that inference, that's steps, those mathematical steps, statistical techniques are nothing but algorithm. Okay, and baby will have certain inference out of it, right? That is what is the process of learning. So algorithm, again, let me just read it out for you. Algorithm is nothing but a machine learning algorithm is a set of rules and statistical techniques used to learn the pattern from the data and draw significant important information from it. And it is the core logic behind the machine learning model. So those are the steps. And then what is a model? A model is a trained entity using a machine learning algorithm. So models are trained using machine learning algorithms, and algorithm like maps down a decision, and the inference which it stores, those are basically kept in a model. So after interpreting that, okay, this particular lady is my mom, whatever inference the baby will keep, right? Whatever the thought process he'll keep. So he'll not say everyone mom, right? That exact characteristics should match so as to be called as mom. That saved inferences are kept in a shell or stored over here. And that's nothing but your trained model. So your kid is trained now to recognize its mom. That is what is a machine learning model. So algorithm are the steps to train, and model is a basic inference out of the entire thing, right? So a model is trained by using a machine learning algorithm. And algorithm maps all the decision that a model is supposed to take based on a given input in order to get the correct output. So that is how the baby will try to adapt that, okay, this are the characteristics of my mom, and those characteristics, wherever it might be kept, those inferences, that's your machine learning model, right? So I hope that these two parameters are clear for everyone, that what is an algorithm and what is a model. Okay, then the next thing is that the predictor variable and the response variable. Now these two are again certain things which we need to basically understand with respect to the data. So predictor variable is it is a feature of the data that can be used to predict the output. A predictor, so say for example, if you want to predict what is the salary to be given to your newly hired employee, right? How would you decide a benchmark for it? On the basis of previous years of experience, right? So previous years of experience, maybe his degree, maybe his marks in graduation, what was the rating given by the previous employer, had he some kind of awards or anything on the basis of his work or not, what projects have he done, all of those things. So like that, some 5-6 parameters you will be seeing, and then deciding that, okay, you need to give this much of remuneration for that particular work or that employee. The features, the columns, the data, the input data which you will be utilizing for predicting the salary, that is predictor variable. So that you basically use to predict, right? And the response variable, it is the feature or the output variable that needs to be predicted by using the predictor variable. So I guess everyone can predict or assume or understand or recognize, right, what is a response variable. So response variable is something which you basically want to predict out. So the salary, the amount of salary what is to be given, that is your response variable. And from what it is to be predicted, that is your predictor variable. Okay, so response variable in general terms is also referred to as a target variable or a target column. Okay, then moving ahead. Now this is again much more fun, and these two are again widely used characteristics. So I'll just decrease this down. Perfect. So training data and testing data. First, we'll try to understand it from the theory part. So the machine learning model is built using the training data, and the training data helps the model to identify key trends and pattern essential to predict out the output. And testing data, after the model is trained, it must be tested to evaluate how accurately it can predict an outcome. This is done by the testing data set. So basically, if I try to tell you this in my own layman language, right? Training data, so if we have an entire full stack of data, right? Like suppose, like I give you 10 entries, and if I ask you to predict what is the salary to be given to a particular employee, you have 10 entries, right? On the basis of which you will train your machine learning model. So you have 10 entries, and on those 10 entries, you want to predict out what would be the outcome. So 10 entries are used, that is your input data. Now, will you take all those 10 entries to train your model? No. Why? Because you will not have anything to check whether your model worked properly or not. So what you will do is, out of those 10, maybe 3 I will take it out and keep it separately, and on the remaining 7, I will train my machine learning model. I will give it to the machine learning model, right? And on those 7 entries, my model will adapt and get trained. Those 7 entries, my model will adapt and get trained, and then on the basis of those 7 entries, after the training has been done, I'll give those 3 remaining entries, those testing entries to the model, and then I'll ask, tell me the answer. And whatever machine will tell the answer, that I'll be comparing with my output, because I already have output, right? So imagine like you have 10 entries, X, Y, X, Y. So X training is a set on the basis of which you give input, all the features which will be used to predict the output. So the entire data, say suppose it has 10 rows and 5 columns. One column will be what you want to predict. 4 columns would be used for prediction. So the column which would be used for prediction and are in the 7 which you are used for training would be called as X train or training set. Similar inline to those, whatever are the 7 outputs, those are called as Y train. So using this, your X train and Y train, the 7 entries, you are training your model. You are building up your model. So this data is called as training data. Now read it. The machine learning model is built using the training data. The training data helps the model to identify the key trends and pattern essential to predict out the output. Clear? Remaining 3 entries, what happens? So the remaining 3 entries, what basically it does is, it takes this 3 entries, the testing X, from which you will be predicting out output, it will give it to the model. Model will predict out something, and whatever the relative output you were having, that would be compared by what output machine has given. Listen it again. X train and Y train, the 7 entries, model has been trained. Remaining 3 would be called as your Y, X test and Y test. X test and Y test, the 3 entries you already have. Right? So X test would be given to the model, the input parameters. Like you will ask the machine that, okay, this is the number of years of experience, this is the previous projects worked on, these are the, this was the particular marks scored in the graduation and all of these things. And now you are asking machine, now tell me how much salary should I give. So machine is giving you an output, say 5 lakhs. But you already have Y test values with it, right? Which is say 10 lakhs. So your model is predicting you should give 5 lakh, but you are telling that it should be 10 lakh. So 5 and 10 is wrong. It should have predicted somewhere around 5. Then you would have said that, okay, the model is working pretty well. So this testing data is used for basically model evaluation, right? So I hope that you have a rough idea about that. What is training set? What is testing set? On the basis of training set, we train the model. On the basis of testing set, we test the model and evaluate our machine learning model, that how worse or how good or how bad it is performing. Right? So this is again an important parameter with respect to the data, what we basically use. And that certainly gives us an idea about what is the machine learning process as well. So if I again try to explain you the entire process, first life cycle, or the first part of life cycle, is to define the objective. What basically we want to achieve. Like anytime, any project whichever you are working on, right? Machine learning, data science, you need to first figure out that what you want to do. So you need to define your objective first. Then around that, you need to do the data collection or data gathering or data mining. So the second step is data gathering. You gather the data, you try to identify the data, you try to fetch the data, you try to get it on board. Okay. Then the third step is preparing the data, or which we call it as data pre-processing. First, you know what you want to achieve. Then you have figured out how do we get the data for it. Once you get the data, it's in the raw, horrible, pathetic form. You need to clean it. You need to work around it. You need to process it and make it readable. Arrange it in certain formats from which we'll be able to interpret it. Once you have that, then you take that thing, and then this is the data pre-processing part. Then you explore it. You try to identify what are the insights in it. What are the conclusions made in it, right? So that is basically your data exploration. Okay, so that is your data exploration part, wherein you try to understand and interpret your insights by performing all different sorts of univariate, bivariate, multivariate analysis. And then once you have a fair idea that what is the current status of your data, so we thought what we have figured out what we want to do. We have gathered the data, we have pre-processed it, arranged it in the best form. We have read the data and gathered insight that what the current scenario about the data is. Then after all of this, we try to build our model. So then comes the model building. After model building, you evaluate it. So you train the model over here on the basis of historic data which you have just gathered, prepared and cleaned. And then after building the model, you check how it is performing. As you need to know, right, how it is performing, whether it is like 60% of the time it is performing well, 40%, 80%, 90%, whatever it is. But you need to evaluate it. And once you do the model evaluation, you move to the next part, which is prediction. So you try to figure out over here that what is to be predicted out of your outcome. What are the answers? What are the predictions which you make from your entire data? Right? You need to do the model evaluation part of it. And after doing the predicting values, you try to tune it further. You try to make predictions much more better by applying again certain processing techniques to it. What we also refer to as hyperparameter tuning and all. Right? And then the cycle like this goes on iterating. I hope that this entire process of machine learning process or statistical process or the life cycle of a project is basically clear for everyone, right? So just to iterate it, first step is to define the objective. We must understand exactly what we are trying to predict. Second step is data gathering. We want to understand what kind of data is to be needed to solve the problem. Is the data available or not? How can I get the data? All these questions are to be solved. Then the third step is data pre-processing. So the data you collected almost is never in the right format, what you want. You will have to inquire a lot of inconsistency. You will have to encounter all these inconsistencies in the data, such as missing values, rendering, redundant values, duplicate entries, outliers, and all those data pre-processing statistical techniques. You will be majorly applying stats over here. And then after doing that, you need to go to exploratory data analysis. So exploratory data analysis is basically a step which we explore the data. We try to understand what is the status of the data. Like suppose I have a huge data of marks of all the students who have scored in 12th standard in mathematics. If I take an average of those marks for male and female, I'll get to understand that, okay, male are having higher average than female, or female are having highest scorers than male, something of this sort. So this is an insight. So generating insights of the process data is EDA. So grab your detective glasses, because this is the stage is all about diving deep into the data and finding out hidden data mysteries. So you try to find out all those metrics in the data which it wants to explore, it wants to be analyzed. And then comes the building a machine learning model process. So this stage always begins with splitting the data into two parts, that is training and testing. So training data and testing data, and the training data will be used to build and analyze the machine learning model, and the logic of model is based on the machine learning algorithm that is being implemented. So right, I told you that machine learning model is similar as to certain steps to reach to an airport from a position, right? Start and stop. So to go to an airport, there could be 10 different processes, right? 10 different ways. Similar is machine learning algorithm. To reach to a certain point, mathematically, there are many different ways. Which way are you using is what machine learning algorithm you are working on. So again, according to that, you'll have to apply and process the data. Once the model has been built, you do the model evaluation and optimization. So after building a machine learning model, by using the training data, it is finally time to put the model to test. So we use the testing data to check the efficiency of the model and learn how accurately it is being predicting the outcome. And then the next step is prediction. So once the model is evaluated and improved, it is finally used to make different predictions and then deployed, and all of those things come into picture, right? But again, a lot of reiteration is to be done back and forth in these 5, 6, 7 steps. Right? I hope that you have a fair understanding about this. Now, in this one, let us try to understand what are the different types of machine learning algorithms. Now, this is one of my favorite topic to tell. So basically, there are a lot of different machine learning algorithms, but basically, if you try to classify them, then the learning process, the machine learning process, right? It can be classified into foundationally into different learnings like supervised learning, unsupervised learning, and semi-supervised learning. And then again within that also there are different classifications like regression, classification, and clustering. So one by one, let us try to dive deep and understand this. So if you try to understand the different types of machine learning steps or algorithms, there is like supervised learning. So supervised machine learning is something which is being used wherein we know what you want to predict, right? We'll try to define it in a better way. So yeah, just to tell you, there are 3 different types of machine learning which can be broadly classified as supervised learning, semi-supervised learning, or what we also refer to as reinforcement learning, and unsupervised learning. Now let's try to understand what exactly is supervised learning. So I'll just fit in this guy over here. So supervised learning is a technique in which we teach or train the machine using data which is well labeled. Listen to me. Whenever you know what is to be predicted, the data is labeled. Your output is labeled. It is defined. You are working under supervised conditions, or it is referred to as supervised learning. So first of all, your data is labeled, that this is Tom, this is Tom, this is Tom, this is Jerry, this is Jerry, this is Jerry. You know the output. You give this data, you do the data cleaning, you do the EDA, you apply your machine learning model, your model is being evaluated, and then at the end, if I give you an image and if you were to tell me that, okay, this is Jerry, this is Tom, your output is pretty much known, classified. You know what your output is. You are working in the form of supervised machine learning algorithms, right? Whenever the output data is classified or you know it is labeled, you are working under supervised machine learning algorithms. Similarly, unsupervised machine learning algorithms would be something where the data is not known for the output, right? See, unsupervised learning involves training by using unlabeled data and allowing the model to act on that information without guidance. So see, if I just move it back, your data, this image, above that image, Tom was written. So the data was labeled. But if you try to come over here, this is Tom, this is Tom, this is Tom, this is Jerry, this is Jerry, this is Jerry. We know because we can recognize as humans, but machine is not having any kind of label. It's just a cartoon standing over there, a cartoon acting over there. It's unlabeled. You have not told the machine that this is Tom, this is Tom, this is Jerry. You have not told the machine. You don't know the outcome. Therefore, there is no one to guide you, right? You have to work around without guidance. You have to find out the similarities. You have to say that, okay, the one which looks like in gray color, it's maybe Tom. The one which like brown and orange and have a big ears and has a tail, thinner tail, fatter tail, something, a thicker tail, something of that sort, it's Tom, right? It's Jerry. The different classifications are to be identified by the machine. Then you take this data, you put it into data cleaning, you do the EDA on it, you check the algorithm, you do the model evaluation, and after that, you still don't know the outcome, but you have classified on the basis of similarities. That these are the similar images, I don't know what to call it. These are the similar images, I don't know what to call it. But see, the classification is done. And that is how clustering and all and anomaly detection and all works. And this is basically your unsupervised learning. Okay, and then reinforcement learning is like a third level, which is a kind of a mix of both, wherein if you just try to understand it by the definition, reinforcement learning is a part of machine learning where an agent is put to an environment and he learns to behave in the environment by performing certain actions and observing the reward which it gets from those actions. So reinforcement learning is mainly used in advanced machine learning areas such as self-driving cars. Now let me tell you how everyone is like known with the Tesla, right? So Tesla is like known for the self-driving cars and all of those things. But how has it learned to drive? How has that machine learned to drive? Now there is some classified data, labeled data, and there is some unclassified data, unlabeled data used. Both are being used. Okay. Now what happens? The machine is given the input of the data when the car is being driven by a human. Observing a human, how it is driving, if the human is driving correctly and the machine is able to adapt that skill set, then the machine is being rewarded. And if the human is doing something wrong, jumping a signal or anything, and the model is also doing the same, the model is punished. So the machine remembers this as a feedback that this was the scenario when the machine got rewarded. This was the scenario when the machine got punished or penalized. Then on the basis of that, it will keep on learning from the live actions of the environment around it and then try to reciprocate around it. And that's how the advanced machine learning algorithms work in the reinforcement learning band. Okay, so I hope that you have a fair understanding about how exactly reinforcement learning works in these two scenarios, right? But again, that is highly advanced machine learning techniques. Now we'll try to understand that which types of machine learning problems we try to solve, or which type of problems we try to solve using machine learning in short, right? Now, the three classifications what we have seen with respect to machine learning were supervised learning, unsupervised learning, and reinforcement learning, right? Now, within this, supervised learning has two classifications, that is classification and regression. And unsupervised learning has clustering, and whereas reinforcement learning or semi-supervised learning is entirely different part, which we just discussed. Classification is something when you want to predict an outcome which is a class or a group. Say for example, you want to predict on the basis of temperature, humidity, pressure. These are the input parameters. You want to predict whether it will rain today or not. So the outcome of this input parameters is a class, is a label, yes or no. You know what is an outcome, right? So supervised learning. And yes or no is a class. So therefore it is of a type classification. So all the problems which would involve certain kind of class, pass, fail, product is purchased, not purchased, yes and no's, true and false, right? Everything, wherever class it is involved, would go under the band of classification, supervised learning type. So all the problems of those sort you can solve using algorithms which are present in classification. Whereas, whenever you want to predict an outcome and there is some kind of value, Say for example, you want to predict what is the salary to be given on the basis of number of years of experience. You want to predict out what is the price on the basis of some 10 different days price. You want to predict out this month's sales on the basis of previous month's sales. A value, a metric, a magnitude is to be formed or predicted or forecasted. Then such kind of problems go under the regression band, wherein you know the outcome, but you want to predict a value, not a class. So we have different kind of machine learning algorithms to deal with them, right? And then later on, wherever you are dealing with a clustering, you don't know the outcome because it is unsupervised, but on the basis of some similar characteristics, we are grouping them up. We are creating clusters, we are creating groups around the same. So those kind of problems go under the clustering band, right? So if I just try to show you, so regression, in this type of problem, the output is continuous quantity, a value. So for example, if you want to predict the speed of a car given the distance, it's a regression problem. Your speed of a car is a value, right? So regression problem can be solved using supervised machine learning algorithms. Example, linear regression. So linear regression is the name of an algorithm which is used in the regression, which is a part of supervised machine learning algorithm. Similarly, classification, in this type, the output is a categorical variable, right? Classifying emails into two classes, like a spam or a non-spam, right? Classification problem that can solve by supervised learning classification algorithms, which are like naive-Bayes, logistic regression. It is one of the very classical and the famous one. It's called regression, but it is a classification algorithm. Okay, there's a beauty behind it. You'll try to explore it in the coming sessions. KNN, which we also refer it to as K nearest neighbor. This is again a classification algorithm. And then clustering, it's like create a group of data according to the features. Similarity is known as clustering. In this type of problem, this involves assigning the input into two or more clusters based on the similar features. So you have some similar characteristics, you take them out and then you group them. For example, clustering views into similar groups based on their clustering viewers of this video maybe into similar groups based on their interest, age, geography, and etc. can be done by the unsupervised machine learning algorithm. Now, if you classify these guys, right, like the people who are having similar interests, similar age group, are from the same geographical locations, you don't know the outcome, what to call these groups. But on the basis of similar characteristics, you are calling them a group, a cluster. For such algorithms, for such problems, we use clustering algorithm wherein you don't know the output. So this is unsupervised. And within that, you have k-means clustering, hierarchical clustering, DB scan, and all different kind of clustering techniques. So those are all different machine learning algorithms which we use. Okay. So a basic classification, if we try to look at it over here, so regression is like a supervised learning, classification is supervised again, clustering is unsupervised. Output is a continuous quantity, a value, a magnitude. Output is a categorical quantity, assigning data points to different groups. Main aim is to forecast or predict a value. Main aim is to compute the category of on the basis of data. Main aim is to group on the basis of similar clusters. Example, predict stock market price. Classify email as spam and non-spam. Find all transactions which are fraudulent and in nature, right? Example of a simple algorithm is linear regression. A simple example which can be used in classification can be logistic regression, and here a k-means clustering. So this is a basic difference between all the different kind of algorithms which we basically use in supervised and unsupervised machine learning techniques. Okay, so I hope that you basically have a fair understanding. Okay, yeah. So I hope that this brings us towards the end of this particular session. But yeah, I hope that you have a clear understanding about what exactly are the different machine learning algorithms which you could use, you could utilize, how they are classified, what are the different terms used, what are the different types, what are the different problems which you can solve with all these different machine learning algorithms. So training, testing, then supervised, unsupervised, regression, classification, and clustering. I hope that it is good for you guys, right? Perfect. Thank you so much for watching. I hope that you are enjoying. This is me signing off. Let's catch up in the next one.